Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is Vitamath 56, and this is a problem on optimization in calculus. So the lower edge of a billboard is 8 sub 1 meters and the upper edge is 8 sub 2 meters above the eye of an observer. At what horizontal distance should she stand if the vertical angle subtended by the picture is to be greatest? So determine this horizontal distance if 8 sub 1 is 4 meters and 8 sub 2 is 9 meters. To help analyze the problem, let's have the figure so that we can set up the equation for the angle subtended by this billboard from the eye of the observer, and let's maximize it. So from the eye level of the observer to the lower edge of the billboard, that is denoted by 8 sub 1, from the eye level or horizon of the observer to the top edge of the billboard, that's called that 8 sub 2. And this is the angle to be maximized. So this is the position x of the observer, and let's derive an expression for this position horizontal distance from the plane of the billboard in order to maximize this angle, viewing angle. So call that theta and call this theta 1 and theta 2. Uh, by the way, in this problem, let's maximize theta, but if you want, also take note that for the property of the angle theta, tangent theta, for example, the angle theta is maximum if its tangent is also maximum. So, therefore, instead of maximizing theta, you can also maximize its tangent if you want, if you find the derivative of tangent simpler than the derivative of the angle theta itself. So remember that the derivative of tangent theta is secant square theta. That is, if you plan to maximize tangent theta instead of the angle theta. But in this problem, I'll maximize theta because it is the original quantity to be maximized in this problem. But as I said, if you want to maximize uh, tangent theta, it's the same thing because theta is maximum if its tangent is maximum. So in this case, I'll maximize theta. Theta is theta 2 minus theta 1 from the figure. And since tangent of theta 2 is 8 sub 2 over x, therefore theta 2 is inverse tangent of h2 over x. Likewise, theta 1 is inverse tangent of h1 over x. So theta equals inverse tangent of h2 over x, then minus inverse tangent of quantity h1 over x. So before differentiating this, imagine that this is u in general, and the derivative of inverse tangent of u is, if you can recall, is derivative of u with respect to x, then over 1 plus u squared. So this is the guide derivative for inverse tangent function. Derivative of inverse tangent of u is du dx over 1 plus u squared. So in this case, the u is h2 over x, and in this case, the u is h1 over x. Also, the derivative of u, or the derivative of h2 over x, h2 is constant, if you apply power formula, you can write this h2x to the negative 1 is negative 1 h2 x to the negative 2, or simply it is the derivative of it is the negative of constant h2 over x squared. So that's the derivative of h2 over x. Then that's it. Likewise, the derivative of h1 over x is negative h1 over x squared. You just use power formula for the derivative. So I'm now maximizing theta by differentiating it. And remember, d theta dx is slope of the tangent to the curve. So at the maximum point, the tangent is horizontal. So that means d theta dx, the slope of the tangent at maximum point is 0. So that's why after we differentiate this expression, we equate it to 0. So d theta dx is negative h2 over x squared, the derivative of h over x, over 1 plus u squared, so over 1 plus quantity h2 over x squared, then minus derivative of inverse tangent of h1 over x is minus negative h1 over x squared all over 1 plus quantity h1 over x squared. Then equate to 0. Explanation, again, this represents the slope between theta and x, and at the highest point, because we're going to maximize theta, that the tangent line to the highest point or maximum value on the curve is horizontal, so the slope is 0. So this is positive term because we have negative negative. So we write this as negative h2 over all over x squared times this quantity here, which is 1 plus h2 squared over x squared. So negative h2 over x squared times quantity 1 plus h2 squared over x squared, then plus h1 over x squared times quantity 1 plus h1 squared over x squared equals 0. So we then transpose this to the right, so this becomes positive. At the same time, we distribute x squared. So in the left side, what remains is x1, h1 over x squared plus h1 squared. So h1 over x squared plus h1 squared equals h2 over x squared plus h sub 2 squared. We then cross multiply, so we have x squared h1 or h1 x squared plus h1 h2 squared equals x h2 x squared plus h1 squared h2 or h2 h1 squared. So for these terms, common is h1 h2. Let's factor out h1 h2. And for these two terms, common is x squared. So we transpose this to the left and write this as h1 h2 quantity h2 minus h1, then equals h x squared quantity h2 minus h1. So we transpose also h1 x squared to the right. So that would be the uh, expression. So we then cancel out h2 minus h1, which is common factor in the left and in the right side of the equation. Then finally, we can derive x square root of h1, h2. So that's the expression for the position of the observer, so that this angle theta is maximized, or we call this the best viewing angle. So that's the position, so that the observer will have the best viewing position. So x is square root of h1, h2. And in the second part, determine this horizontal distance if h1 is 4 meters and h2 is 9 meters. So that horizontal distance is square root of 4 times 9. So therefore, x is 6 meters for this particular data. So that's it, and I hope that you were able to follow the explanations and the solutions. Just review calculus for those who are already graduates of engineering, because this problem is common to engineering courses.